Hello, in this session what we will do is take a look at the many different ways Java EE or Jakarta EE applications can run on the cloud. In this particular case we'll be using Azure. Azure obviously I believe is particularly well suited for running this type of applications. But quite honestly you could use any major cloud to do similar things more or less. But obviously in this case we'll be focusing on Azure. Feel free to obviously take this talk and adapt it in a different way. So my objective is not to do a lecture. My objective is to actually show you how to do all of these things. And in fact, instead of a slide, what I will have is a GitHub repository. So this is the URL of the GitHub repository. It's essentially one of the most popular repositories on my own personal GitHub account. Should be relatively easy to find. So what I will do is essentially run demos end to end, slideless for the entire session. There's no slides, but what you do have is step-by-step instructions on doing everything that I will be doing today in the next hour or so. So you should absolutely feel free to run this talk by yourself and explore this code base through the GitHub instructions by yourself. In fact, these instructions are actually geared towards a one-day lab, hands-on lab. So we won't be covering all of the material here. That's not really possible in an hour time frame. But what I definitely will do is show you just enough so that you definitely get a feel for what is going on with Java EE on the cloud and Java EE on Azure in particular, and give you enough material so that you can take a look at the GitHub account and get going by yourself. So the first place we should start is on-premise, essentially on your own physical machine. And show how all of this stuff runs on-premise locally on your laptop first before we do anything on the cloud. So this is what we'll do throughout is basically use a simple Java EE cloud application. Not very fancy, but it does use quite a bit of Java EE / Jakarta EE8. So we're using JAX-RS, CJB, CDI, JPA, JSF, and bean validation. Full suite of things should be definitely enough to give you a flavor of how this type of application would look like on the cloud. What we will do here is spin up this application locally using our IDE, Eclipse in this case, but you could use any Maven capable IDE. The application isn't IDE specific, it's just a Maven application. In fact, you could probably run it purely on the command line if you so wish. We happen to be using Webster Liberty in this case, or rather, sorry, Wildfly in this case, but you could use Webster Liberty, Pyara, or any other Java EE8 / Jakarta EE8 compatible runtime. We'll be using Postgres, but again, you can use any basically database that would work with JPA. All right, so I do have all of my setup done here. I will cheat a little bit here and there for this talk just to save a bit of time. So I do have JDK8 installed on this machine. I have Eclipse IDE installed. I've installed Docker. We'll be using Docker a bit more extensively a bit later, but it's also convenient to use Docker even for this on-premise sort of on my laptop demonstration. I'll explain why in a second as we go along. I do have this code installed locally on my machine. I will need that to move forward. So this is basically a database-driven application. You do need a database. I could have installed the database, in this case Postgres, locally on my own machine. But in fact, there's no real reason to do that. I'll be using Docker and for the Kubernetes portion of this demo anyway. So I just want to use Docker for running the database. That way I don't really have to install anything specific on my machine. It's very ephemeral. I just start it. It'll go and download Postgres from Docker Hub, run it, and as soon as I shut down the Docker container, I don't have anything else installed on my machine other than Docker. And the Postgres instance just sort of goes away. So let's go ahead and start the database instance via Docker. If you haven't seen Docker before, I'll talk you through it just really quickly. So here we go. I'm copying and pasting the instructions that I have from my GitHub account again. So you should again be able to do this and replicate this yourself. So basically, I'm doing a Docker run of the Postgres image that exists in Docker Hub. I'm giving it this image a name, and I'm also doing a little bit of file system mapping. You don't need to know about a great detail of that quite yet. I do need to expose a port. So the port I'm exposing via the -p parameter, as you can see here, is a 5432. This is because essentially every single Docker instance is sort of, you can think of it as behind its own firewall, so you can't really access it. So in order to be able to access it from localhost, meaning my own machine from an IDE, I need to expose that port. So that's what I'm doing. I'm exposing port 5432. So let's spin this up and see what happens. Okay. Unable to find the image locally. I am on a relatively fast network, so what is going to happen here is that Docker will determine that, hey, I don't have this, I don't have Postgres copy locally, so I need to go and download Postgres, which is it's going to go ahead and do, and then it's going to just start up Postgres right on the fly. As you can see, just started right up. The database is now up and running and ready to accept connections. Okay, so now let's go over to the IDE. In the IDE here, I already have the application set up. It's called Java EE Cafe. You'll see in a moment why that is. I'll open up the POM XML. It's a super simple application. Really, it's the way most canonical Java EE applications or Jakarta EE applications should look like. Really just one dependency on the Java EE APIs, in this case version 8, which I've specified up here. And that's it. And there's really nothing much more to this application. I do have a bit of setup that I've done. I'll go over that in a second. After I run the simple demo, I'll also show you the code a little bit as well. So I do have Wildfly 17 up and running. I do have it registered with my IDE here. So I'm going to just run this application. I've done a little bit of setup beforehand. Namely, I've set up the data source for this application to connect up to the running Postgres instance that I have. All right, so let's go ahead and give this a spin. I'm going to right click this application. I'm just going to do a simple build. So run as Maven install. And it should go without a hitch. So there we have it. We have our thin var. It's a pretty simple and small thin var. And we're going to run this var file on Wildfly. So I'm going to right click now and say simply run on server, and that's going to start up my Wildfly instance and run the application. And it should open up the application in an inbuilt browser in the IDE. As you know, this is a relatively well understood feature of Eclipse. Okay, so there's my application. It's running on localhost port 8080, which is the default port for Wildfly. As you can see, I've pre-populated the database with a bit of data. So I have two instances of coffees here. I have Reza 1 and Reza 2. I won't bore you by showing you the entire data, but basically what you can do here is create a new coffee instance as well as delete the coffee instances. So there's your basic CRUD functionality here. I'll show you a little bit about the application itself, not too much, just so you get enough confidence that this is in fact a Jakarta EE or Java EE application. So we'll go and take a look at the Java resources. And what we see here is there is a REST interface. I'll show you the REST interface. It's a JAX-RS based REST interface, as you see. Publish under path coffees, and then I'm injecting a repository instance in here. And basically it's a CRUD interface. So I have get for all of the instances of coffee. I have post to create a new instance of a coffee. I have get a particular instance of a coffee. I need that to show some of the details of a particular coffee. And then I have a functionality to delete a coffee instance. Behind here is a entity object that I'm referencing. Pretty simple entity. It's the coffee entity. And it looks like things are just a bit sluggish at the moment. What we'll do here is simply open this up through the resource. It's a bit faster. Okay, so here's the coffee entity. It's a JPA entity, and we have a generated ID and really just two data points, the name and the price, and that's really it. As you saw from the screen itself, There's also a repository behind this. Okay, it's a simple CRUD repository. Just injecting a persistence manager. You could even use Delta Spike data to further abstract this repository if you wanted to. I didn't bother. This is just a stateless session being for me, and I'm injecting an entity manager and doing some simple operations to do essentially add, remove of entities and finding the coffee beans themselves. There is a JSF backend to this. I won't bother showing you that. The JSF backend, what it is doing is that it is invoking the REST interfaces behind the scenes, similar to what you would perhaps do using Angular or Vue. So that is it in terms of what I want to show you of the application itself. So let's minimize the IDE, but I do want to show you a little bit of the setup that I have done behind the scenes. So this is the application. It's a Maven application, nothing special about that. Under the server directory here, there are a few steps that I have taken, and all of the steps are actually outlined here, so you can replicate them yourself in your local environment. But basically, this is what I've done. I need a Postgres jar file. I've downloaded and installed that, and put that in the library directory for Wildfly locally here on my machine. The Postgres jar file must be accompanied by a module.xml just to register it with Wildfly. So this is what it is. It's a relatively boilerplate. Nothing much more going on really here. And I do have a custom standalone.xml file. And really the only big change that I've done here is that I've specified the database, which is right here, as you can see. Okay, so I've given it a JNDI name, and given it a name of the pool, and basically I'm connecting up to localhost port 5432, and that is working because I've exposed that port under Docker, and that's really it. Right? There's nothing much else going on here. All right, so that is it in terms of my local installation of this application and running you and showing you how this works in the old-fashioned way. Now let's go and take all of this stuff and run it on the cloud. So the first, there's a couple of many different ways that we could do this, certainly on Azure. I'll give you a description of what they are and sort of what I will cover next. So the simplest way to do this is just use virtual machines. So this is very similar to what you would do perhaps in your own data center, except that you're doing it on Azure instead. You're literally creating an instance of an operating system and doing whatever you need to do in order to get the environment ready for this application and then deploy the application and run it. So that would be IaaS. On the opposite level of abstraction is PaaS, or Platform as a Service. So in this option, what would happen is you would do very little in terms of environment setup. You really don't care about things like operating systems and so on. You just want an instance of Wildfly is going to be managed for you by the environment. And we do have such an option available on Azure. It's essentially App Service Linux Wildfly. It's a fully managed instance of Wildfly that you don't need to worry about the kind of things you would worry about for Docker and Kubernetes or IaaS. Everything is relatively abstracted for you. We can also run this application purely using Docker. So I'll show you in a moment how you can take this application and Dockerize it, and you can run that Docker image using Azure container instances, right? So this is something a lightweight usage of Docker, if you will, on the cloud. And of course, above and beyond that, you can go whole scale with containerization and use Kubernetes. Azure has a very good Kubernetes implementation, Azure Kubernetes Service. So you can you take full advantage of every single thing in the container ecosystem and deploy this application using Docker and Kubernetes as well. So I won't be able to show you all of this in an hour time span. What I'm going to aim to show you is perhaps the simplest option, which is containers and IaaS. If you're new to the cloud, this is how you would typically probably start with to get yourself comfortable. It's very close to how things would be if you were running on-premise. And I'll show you the most popular option. And the most popular option these days really is Kubernetes. So I'll show you the Kubernetes way of deploying this application to the cloud, to Azure as well, and then I'll let you explore the other two options, namely the Azure container instances or just plain Docker, or the fully abstracted, fully managed Wildfly by yourself as well. the idea here is very, very similar. So once you especially take a look at the Kubernetes way of running things, those two ways will seem more or less pretty natural and not really all that all that mystifying. So let's go ahead and start with Azure Linux containers. So this is again very similar to what you would be doing if you were doing this sort of by by yourself in your own data center, except for the data center in this case obviously is Azure. So similar to how we started the database, which actually we don't need anymore. So I'm going to just shut down this database. I just hit Control-C. Now the database is shut down. I don't need the instances of a database anymore. And in fact, I'm going to shut down Wildfly as well, just for good measure. So Wildfly is also now shut down. So just like I had a database instance running locally, I need a database instance running on the cloud, and there's many different ways you could do that. But the easiest way is just to use a PaaS. So we do have a Postgres PaaS option on Azure, and in fact, I have the steps outlined here on how you would go about creating that through the Azure portal. This is not really that fundamental to the Java EE side of the story, so I'm going to skip this over, cheat a little bit, just for the sake of time. So I've already created a DB instance, managed version of Postgres here. So it's called Java EE Cafe DB / Reza. If I go in here, you'll see that it is deployed onto Azure already. This is the Azure portal if you haven't seen it before. It is deployed in the central US location, and I have basically a running instance of Postgres that I can access and use, and that's what I'm going to be using for the next version of my demo, where I'll be running this application on the cloud instead of running it on my own laptop. Okay, so moving forward, first thing we need to do in order to get this running on the cloud using virtual machines is create the virtual machine. How do we do that? Well, that's what I'm going to show you now. So first thing is to go into the Azure portal and create a virtual machine. In this case, we're going to be using Ubuntu. It's a popular Linux distribution. So let's go ahead and go ahead and create that. And I'll be flipping back and forth between these instructions and the Azure portal. You can do all of this, by the way, using something called the Azure CLI or other mechanisms as well. But the Azure portal is sort of a beginner-friendly way of doing a lot of these things. So we're going to go to the Azure portal, and we're going to try to create a resource. And what we are going to do is, you'll see several categories here. The category that we're interested in this case is compute, and that's more or less a synonym for IaaS, or infrastructure as a service. And there's various VMs VM images that I could use here, that I could start with. But the one I'm going to start with is Ubuntu. Okay, so I'll go ahead and hit Ubuntu here on the portal. I'm presented with several options. First thing you'll need to do is choose a resource group. This is more or less, you can think of this as a logical data center grouping. So I've created one already. It's called Java EE Cafe Group Reza. I'm just going to reuse that one. So that's where, for example, my database also resides. This is just a way of thinking about this entire deployment a bit easier. I do need to give the virtual machine a name. So the name I'm going to choose here is going to be Java EE Cafe Server Reza. I'll choose my own suffix for that. So I'm going to just go ahead and copy and paste this from my instruction set. I need to give a name here of Reza. Okay, so this virtual machine is called Java EE Cafe Reza. It happens to be running Ubuntu. As a region, I'm going to choose Central US. So the same one as where I have my Postgres instance running, just to reduce the latency a little bit. I don't think I need to change, so I do need to specify a username and password. You can use SSH to access this machine, and we will be accessing this machine in just a moment using SSH, but I'll be taking it a little bit easier. I'll be using passwords instead, so a little bit old-fashioned, but still works just fine. So I'm going to specify Wildfly as the username to access this virtual machine remotely. So here we go. And I'm going to give it a suitable password, nothing too complicated, just something to get by just for the demo. So I'm going to just enter the password here and confirm the password here. And I believe that is really all I need to do. Oh no, there's a few other steps we need to do as well. So by default, again, this virtual machine won't be accessible to the outside world. But we do want this to be accessible from the outside world. One is we need to go ahead and do some setup steps on to this machine, and we also want this application to be available on the internet. So I actually need to allow this virtual machine to be accessible from the web. So I need to open up a certain select number of ports. So the ports that I'm going to open up are HTTP port 80. Okay, this is where I'll be accessing my web application. I do want HTTPS access, and I do want SSH access as well. In fact, SSH is what I'll be using in order to set up the rest of my application. So I'll choose SSH. So those are the ports that I need open. I don't need RDP just because I won't be using RDP in this case. I'll simply be using SSH instead. Do I need to do anything else here? No, I don't. So we're basically ready to go. And we're going to go ahead and do a review and a create and get our virtual machine set up. So it's running the validation. It says validation passed. There's no issues with the settings, the default settings that I've created so far. So I'm going to go ahead and create this image. Now this is pretty remarkable. This never ceases to amaze me. Back in the day when you needed to do this on your own machine, you need to rack and stack a machine or do a whole bunch of probably days worth of work before you can get a machine up and running. This will just happen in just a few minutes, right? It's pretty remarkable what is going on here. But as this is going on, it's going to take a few minutes for this to deploy. As this is going on, let's take a look at a little bit more greater detail into our application and what we will be doing next. Okay, so this is what we'll be doing next. So as you can see, there's not a lot going on that is different. We will be more or less taking the Java EE application that we had deployed on-premise, but we do need to make a small change, and that is that our standalone.xml will be a little bit different, right, than what it would have been on-premise, obviously because local host doesn't make any sense here. So we need to specify where our application, where our database is actually running, and so that is the difference here, right? So as you can see, I've specified that the Postgres instance in this case is running on Azure, right? So this is the Azure URL where I have my managed instance of Postgres running, and I have to specify a particular username and a particular password, right? Actually, you'll be able to find all of this information if you looked in my resources tab and looked into the managed database instance. It will tell you what this URL should look like. There's a specific section that says that has this information for you, and it will also tell you what your username and password should be in order to be able to connect to this virtual machine. Okay. So next, we'll be going through several steps beyond this. So we will be basically doing the installation that we would have done on-premise if we were starting from the operating system layer up on this virtual machine, once this virtual machine is actually allocated. So the first thing I'm going to do is I'm going to SSH into this box using an SSH client, and this is how we'll get the public IP address in a second. We'll actually be able to cut and paste that. So my deployment is complete. So let's go ahead and actually do the steps as well. Right, so we'll go ahead and connect up to SSH. So as you can see, it'll tell you your deployment has succeeded. So now I have a running instance of a virtual machine that is publicly accessible on Azure. It took just a few minutes to do that. The next thing I'm going to do is go ahead and connect up to this instance. So you'll notice a little bit of there's a prominently visible connect tab here. So I'll click on the connect tab, and it'll tell me how I can access it via SSH. Right. So I'm simply going to copy this information from here. So this is the SSH information that I need to use to access this machine. I'm going to go ahead and copy and paste it onto my terminal and hit enter. It's telling me whether I want to accept the certificate. Yes, I do. And I'm going to give it the password that I had specified earlier. Oh, looks like I mistyped that. Okay, so now I'm actually on that physical machine or running on Azure, And now I can set up my application. I can get everything that I need to do done in order to get the application up and running. So the first thing I need to do is do a sudo apt update because I want to install JDK 8. And by default, the Ubuntu image that is there will not have that definition yet. So I simply briefly need to do a apt update. So now Ubuntu knows everything that I need to go and install on this machine. So first thing I'm going to do is install OpenJDK. Yes. And now OpenJDK will install in just a second. As I said, I'm on a relatively fast network. This won't take very long. And the machine you're being allocated on Azure is also relatively beefy machines. It's definitely not your run-of-the-mill sort of machine you would get a few years ago. So this should finish relatively quickly. Okay, so now I have Java. Just to verify, I will say java-version, and there's my OpenJDK version running. I happen to be running JDK 8, which is more than sufficient for this application. Next thing I need to do is install Maven. Normally what you would do here is this step wouldn't really be necessary because you will be deploying through a CI/CD pipeline. But in this case, I want to keep it pretty simple, stupid. So I'm going to actually build the application locally on this box. So in order to do that, I need to install Maven. So I'm going to do that next. And this should be relatively quick as well. Great, Maven is installed. Next, we're going to get JBoss because we need, or rather Wildfly in this case. Wildfly is accessible on the web, so I'm just going to do a wget to get a copy of Wildfly onto this virtual machine. Alright, and the zip file to be downloaded. As you can see, this is a zip file. I need to unzip it, so I'll need to get the unzip utility installed real quick on this machine as well. It's a relatively small utility. I'm going to unzip Wildfly next. Alright, and Wildfly is ready to go. So now we need to do a bit of setup. So the first thing we need to do now is actually download the application itself. So in this case, I'll be downloading the source code onto this machine and building it there. So I'm going to do another wget. In this case, I'm going to actually download this source code repository. Onto this virtual machine. So here we go. All right, it's a small file, really nothing much more to it. I'm going to unzip the application. It's unzipped. I'm going to next build it, so I need to cd into where this application actually is. All right, which is under Java EE Azure Master, and under Java EE, and under Java EE Cafe. As you can see here, I have a POM file here, so I'm going to go ahead and build the application using Maven. Okay, and there's my WAR file. It's under target. I think there's no need to really show you that. I'm going to go back to the home directory and finish the rest of our installation. So we're now going to do whatever is necessary to get Wildfly ready to run this application. The first thing I need to do is install the Postgres drivers. In order to do that, I need to create a directory under Wildfly to install the modules. So I'm going to do that next. It's mkdir. And under Wildfly modules, I need to create a Postgres subdirectory. So creating that now. All right, that is done. Next, I need to copy over the Postgres drivers, the driver jar file, onto that directory that I just created. So going to do that next as well. All right, and I need to copy over the module.xml to go along with the jar file. All right, now I'm going to copy over the standalone.xml file. Remember, this is pointing to the managed instance of Postgres running on Azure. And finally, we are going to copy over the WAR file that we just created locally. Okay, all that is now remains is to start up my application and show you that it is running on the cloud and accessible publicly. So in order to do that, I need to switch directories into Wildfly, into the bin directory of Wildfly, and start up Wildfly. Okay, and what is going to happen here is that we're going to open up port 80. So that is the other bit of configuration that is in the standalone.xml file. Instead of running on port 8080, we're running on port 80. So I will need to run as super user before I'm able to do that. So I'm going to go ahead and quickly su into the super user. Okay, I'm now su, and now I can start up Wildfly. And you should be seeing that basically what's going to happen here is very similar to what would happen in the end on my local installation that I already had set up. So let's go. Excellent. So now my application is running. So it is now deployed to the cloud, and as you can see, it's not terribly different from what you would normally do in perhaps your own on-premise installation. It's super simple to do, but it is running on the cloud. The application that is now my Java EE application is running on Azure. So how do I verify that? Well, first thing I need to do is find out the public IP address of where this virtual machine is running. And then simply access my application. So that's what I'm going to do. And how do I do that? Well, on the same overview tab, you'll see a public IP address. This is the public IP address where this virtual machine is available. If you wanted to, you could front end this with a load balancer, or even specify your own public IP, your own public DNS to this as well. But regardless, let's copy this over and then open up a browser and hit enter here. So here I have Wildfly running. So this is my application that I'm just accessing through the browser. It's a public website that is running on Azure. I'm going to go ahead and access my application as well. Sorry, typo. And there's my application. I won't bother installing anything here. It should be just exactly the same as it is on premise. For the interest of time, let's skip this over and now move into the Kubernetes portion and sort of show you what the differential is between running it in the IaaS way, which is sort of the bargain basement easy way to get into the cloud, versus a most popular, perhaps the most popular way that we know of these days, which is using container and Kubernetes, and show you how that really looks like in terms of a difference. Okay, very good. So I'm going to now exit out of this machine. I don't need it anymore. So I'm logged out of that virtual machine back into my regular environment here. Okay, and then we'll sort of effectively starting from scratch and doing the same things over, but this time using Kubernetes. So again, I'm skipping over the PaaS option. Definitely feel free to take a look at that. It's a very compelling option if you're not that interested in all these infrastructure concerns and just want to focus on coding and deploying onto Wildfly. Again, if you like containers but don't really want to deal with Kubernetes, there's a nice way of doing that on Azure as well, called Azure Container Azure Container Instances. Feel free to take a look at that. I have instructions for that as well. But right now, we're going to move over our tour onto Kubernetes and showing you how all of this stuff works relatively well with AKS and Kubernetes. So you do need a little bit of setup to go here as well. Again, I've specified everything step by step here, so you can replicate these steps yourself if you so wish. Again, you'll need a managed Postgres instance. Again, I've already done this. It's already there. So if you look into my resource groups and jump into the resource group that I have set up here, there is effectively my database instance sitting right there. By the way, if you scroll a bit down now, you'll be able to see our virtual machine that we had created earlier. So there's my virtual machine Java EE Cafe server. Either way, the database is up and running for us. We don't have to do this step for this. In fact, I've cheated a little bit as well with this with the setup and creation of the Kubernetes cluster as well. As you can see, I wanted to show you that in the virtual machine. It does take a few minutes, which we don't necessarily want to utilize here. But basically, what is going on here is if you go into my resource group and you go into the resource group settings here, I already have a Kubernetes cluster created ahead of time. It's literally just a single step that you need to do that. Here's the fancy instructions to do that, and in fact, it's just one line. If you are using the Azure CLI, it's one line to create a Kubernetes cluster. It does take a little bit of time though. It should take about between 5 and 10 minutes, which we can, I think, better utilize showing you something else or explaining something else to you. So here's my Kubernetes cluster. As you can see, there's a Kubernetes version. It's running in central US. It does have an API server address. It is essentially publicly accessible. I do have a couple of node pools, right? So I have three nodes running here, whereby I can create pods. And there's some other interesting information here, as we'll see in a second. In fact, I'll show you right now. If you click on the Insights tab, you'll see a little bit more information about what is going on with this Kubernetes cluster. We'll revisit this in a second. This is actually one of the plus points of Kubernetes. All right, so basically I've set up the Kubernetes cluster already. I've set up my Kubernetes tooling to show you what I mean. Let me do kube control, and then what I will do is pods, or rather, pardon me, I'll do nodes. Rather, what I meant was get nodes. Okay, So if you haven't seen this before, kube control, you can think of it as basically the command line for Kubernetes. So all of the interactions with Kubernetes will take place using this command line tool. It's almost as though you're running Kubernetes locally, but what is really happening is that all of the issues, all of the commands that you're issuing, like the Kubernetes get nodes command that I just issued, this is running against the Azure Kubernetes instance running on the cloud, and it's getting the information from there, and will be interacting through kube control there as well. So there's a little bit of a steps here to get kube control connected up to your cloud. I've outlined what these steps are. They're really not that difficult. So you just need kube control installed, you need the Azure CLI installed, and you need a single command that says, hey, please go and connect my Azure Kubernetes instance with kube control using this one AKS get credentials command. If you haven't seen this before, the AZ stands for basically the Azure command line interface. Okay, the other thing I will need is a Docker Hub account. So in order for this application to land on Kubernetes, it first needs to be in a repository somewhere. So you could use the Azure Container Registry, and the big benefit of using that is that it is private. Nobody else is able to see what images that you're using with Docker and Kubernetes. But in this case, I don't really need that per se, so I'm just using Docker Hub. So I'll be publishing my my Docker image onto Docker Hub, and you'll be able to see it there. So at the moment, as you can see, this is my Docker Hub account. There's really nothing there, no repositories whatsoever, but there will be something there in a moment as we go along. But bottom line is, I'm using a Docker Hub instance. If you wanted to, you could use the Azure Container Registry as well. So the first step for me here is to build the application, and there are some subtle differences between this application and the one that I was using before. But I don't need to go through all of this. I've basically cheated here, and I've created a WAR version, a WAR file already, and copied it over. And I'll show you where that is. So this is under GitHub. This is my local machine. And if you go into the Kubernetes directory, I already have a WAR file sitting there, just waiting for me. I've just pre-built this WAR file to save time. And this is the WAR file I'll be packaging up, and packaging up using Docker, and then deploying onto Kubernetes and deploying onto Azure using Kubernetes. As you can see, it's tiny. It's a 14 kilobyte thin WAR file, very typical of how it would look like using a Java EE or a Jakarta EE application. So all of that stuff is essentially done. So I've set up the standalone.xml file here as well. We will need a specific standalone.xml file. I'll show you all of those steps in a second, but there are some artifacts that you will need in order to be able to create your Docker image. So basically everything that you need to run the application needs to effectively be in the Docker image in one way or the other. So bottom line is, I now have my WAR file created. I'm going to just go ahead and package up this WAR file in Docker next. So let's do that. So I'm going to first cd into where I have this code base installed. Alright, so this is my directory. There's a WAR file sitting around in there for me that I've already copied over. Next thing I'm going to do is do a Docker login. This is to make sure that I'm logged onto my Docker Hub account locally. So let's go ahead and do that. And yes, I've logged in now, so I can now begin uploading building my Docker image and then uploading it up to Docker Hub. So that's what we're going to do next. So the next step is to build the Docker image, and I'll show you what's going on in a second after we do this. So I'm going to copy and paste this command, and I'll describe to you what this command is if you haven't seen sort of Docker before. So I'm building my Docker image. I'm going to give it a name, Java EE Cafe, and give it a version, which is version 1. And essentially what I'm saying here, the dot stands for look in the correct directory. In the current directory, there will be a file called Dockerfile that describes how this Docker image should look like. But I'm also going to give it a name here, because ultimately my goal is to publish this image out onto my Docker Hub. So let's go ahead and get started with that. So my Docker image is now built. As you'll see when I show you the Docker file in a second, basically what is happening here is very similar to what would happen if I were to doing this in the VM style, except that it's a lot shorter and much more repeatable, and you need to do much less typing because effectively everything is set up in Docker and Kubernetes for you. So I'm downloading Wildfly at the moment, but it's not just Wildfly. It's actually also downloading the operating system as well as the JDK build as well. So that's the first step that is taking place in building the Docker image. And the rest of the steps are relatively quick. So I will show you what actually happened and what each of these steps are. So first thing is my base image for this Docker image is JBoss Wildfly. Then I am basically going through the same steps that I basically did when I was doing the VM instances. So I'm creating a directory to install the Postgres jar file. I'm installing the Postgres jar file, copying over the module file, copying over the standalone.xml file, and then finally copying over the war file. So this is effectively describing how my Docker image should look like. How does each individual machine in my Kubernetes cluster look like? And this is effectively how it looks like. Once this is up and running, it will basically run the application as though the same way I was running it in a VM environment. So the next step for me is to actually publish. So there's a few more artifacts. There's a Docker file, as you saw. There is a Java EE cafe.yaml file that I'll describe in a second. This has to do with Kubernetes. And the module.xml file you're already familiar with. This is jar file, and this is the standalone .xml file that is describing the Wildfly configuration. So next, I'm going to push this Docker image onto Docker Hub. Alright, so it is, in a moment here you will see that this image will show up on my Docker Hub account. So let the push finish, and the push is finished in fact. So let me refresh my repository now, and as you can see, this Docker image is now published onto my Docker Hub account, and it is ready to go, ready to be used by any Kubernetes instance. In this case, obviously we're going to use the one that we just created before. So next step for me is to take this Docker image and create a physical deployment out of it. So deploy this Docker image onto Kubernetes and actually instantiate copies of Wildfly. And as you'll see in a moment, what I will do is spin up 2 instances of Wildfly, not just one instance of Wildfly, using this YAML file. So let me go here and execute this YAML file. Once this file is executed, I will show you what the contents of this file actually looks like. So let me go ahead and issue this kubectl command, and what we are doing is creating the actual Docker image instances on Kubernetes. So let's do that. And now it is actually created. Next thing I need to do is monitor. So I'll show you the contents of the Java EE cafe.yaml file in a second, but in the meanwhile, what I need to do is see if when the service, in particular the load balancer that is serving this application, is going to be ready. So it's not going to be ready instantaneously. It is going to take a little bit of time, as you'll see in a second. So I'm going to just copy this paste command, and I'll explain to you what this command is doing, and then we'll go back and actually take a look at the Kubernetes YAML file and see what exactly went on there. So what I'm doing here is getting a service by a name, and you'll see where this Java EE Cafe service is defined in a moment, and I'm watching for when this service comes online. Okay, so as you can see on this line of on values, there is an external IP column that is not quite populated yet. It says it is pending. So that is what we need to wait for a few moments. It's just going to take a few minutes for this external IP to get propagated. And while this is happening, let me show you the Kubernetes portion of this application and what the settings for that really looks like. So this is a Kubernetes YAML file. And you can obviously take a look at that yourself later on after this talk is over. And basically, this is describing how your data center should effectively look like on the cloud. How does your Kubernetes cluster look like? And so the gist of this is that we are taking a container image that happens to be running my container image here and creating two copies of it, two replicas of it. So there will be two instances of machines running that Docker image with Wildfly and all of my Wildfly configuration, as well as my WAR file running there, and there will be two VMs that are spun up by Kubernetes. So how do you actually load balance between those two? Well, that is also a Kubernetes service, and that is the service, in fact, we are waiting for. So the name of that service is Java EE Cafe, as you can see, and it is a type of load balancer. So it is actually going to load balance across these two instances of Wildfly that Kubernetes is going to create for us. And what we're also doing is doing a bit of port mapping. So we're mapping port 80 to port 8080. So these two instances of Wildfly, I haven't changed their setting on it. If you look at the standalone.xml file, they're running on port 8080. So in order to be able to access it from the web, I need to specify that I want to map it from port 80 to port 8080. So that is the work that the load balancer is going to do for us in a moment, and you'll see that in action. So we do have an external IP now, so I'm going to Control C out of this. So I'm going to just copy over this public IP address. So this is the IP address of the load balancer on my Kubernetes cluster. So let's access that. And as you can see, here we have another instance of Wildfly up and running, right? And this is in fact running our application as well. And there's our application running, this time not in a virtual machine, but rather running on Kubernetes. Let's just add a instance of a coffee here. Okay, so there we have it, one instance. We'll add another one. Okay, so we have two instances of the coffees running here. I'm going to just show you how it looks like in the REST interface. Okay, so there we have it. That is the REST interface behind the scenes that is running this. So to go back to the instructions, this is basically the end of the instructions for Kubernetes. We basically have your application up and running now. What you can experiment with is Kubernetes can also auto scale these instances for you. So let's say you wanted 3 copies of Wildfly running instead of 2. So you can easily do that by simply using the scale command in Kubernetes to do that. Now, some of the other nice things about Kubernetes is a lot of, in many of these cases, so first thing you should note is that how simple this was, right? So if you were to do that in the past and you were to set up Wildfly with a load balancer in front of it, there's a whole bunch of configuration that you would have needed to do. All of that configuration essentially goes away. So all of that is handled by Kubernetes. The deployment, rolling deployments are also handled by Kubernetes as opposed to handled by the application server. And basic monitoring is also handled by Kubernetes. So if you go into the Azure monitor, in this case, Azure Insights Monitor, you will see that Azure Insights Monitor will actually show you information about CPU utilization for each node, memory utilization for each node, some activity counts, and so on and so forth. So a lot of the information that you would have seen from your application server console is now available inside of the Kubernetes environment instead. And you can take a look at very in-depth information about all kinds of things that are going on in the container and Kubernetes environment. So basically what happens here is that a lot of the your information that you would have done in IaaS is all automated. It's basically all repeatable. You can run the same Docker file locally if you so wanted, and you can take the same Docker file and run it on Kubernetes. You have to deal with infrastructure a little bit, but not nearly as much as you would in IaaS. Whereas in PaaS, it would be even more abstracted than this would be. You really would have no concerns about things like operating systems and so on. All of those would be managed for you, and a lot of the things that you would have done manually is basically handled by the Kubernetes environment itself. So that is the big differential between Kubernetes and why it's somewhat justifiably pretty popular. So I hope you got a flavor for how easy it is to run a Java EE or Jakarta EE application on the cloud. There's many different ways of doing this. There's really nothing holding you back whatsoever. I just showed you two different options of just on Azure, and there's many other options on Azure as well. And all of these are mostly equivalent, right? If you look at other clouds, they will also have similar features more or less. So really, all the power to you. If you're a Java EE and Jakarta EE user, the cloud is your domain. You should be perfectly comfortable and have many different powerful choices on the cloud here. I hope this is useful. Feel free to take a look at the GitHub URL. Feel free to check out the code. Hopefully this will be the beginning of a long journey for you on the cloud using Java EE and Jakarta EE.